Here's a screencast on naming chemical compounds. It's important when we're talking about these different elements bonding together that we're able to name the different chemicals that we're producing. So we're going to walk through the different kinds of compounds, how you know how to name them, etc. So first of all, we're going to look at the ionic compounds. How do we name them? Whether they're monoatomic, which means an ion dealing with one specific atom, one single atom, or are they polyatomic, which some atoms or some ions are made up of more than one atom. And we're also going to look at how to name molecular compounds. So first we'll deal with ionic compounds. Next we're going to deal with molecular compounds. So as far as naming ionic compounds go, recall that an ionic compound consists of an anion, which is going to have a negative charge, and a cation, which is going to have a positive charge. So anions are negative because they gain electrons, nonmetals gain electrons, and cations are positive because they're metallic and metals are very readily lose electrons. So when you have these anions and cations together, opposite charges attract. That's your electrostatic force, your electrostatic attraction, and that's what's going to hold them together. That's what actually is the ionic bond. So we're going to work with a goal here when we're talking about ionic bonds. We're going to try to name this thing. We're going to try to name this this compound that's formed when sodium and chlorine bond together. So first of all, if we want to be able to name this, which is our goal, we need to know how it forms. So if you allow me to show you, we've got sodium, and recall with our Lewis dot structure, sodium has one valence electron. Chlorine is over in group 7. It has 7 valence electrons. Neither of these atoms are stable because they don't have a full valence shell, but this is easily solved if we transfer this electron over to here. Now this valence shell is gone. It moves to the next inner shell, which is full. Alright, this electron now has a partner, so that valence shell is full, and we form this ionic compound with our cation and our anion, and they're attracted to one another by the electrostatic force. So we're going to keep this compound in mind, this ionic compound, this monoatomic, because we've got one ion, or monoionic, I'm sorry, and this ion, which is just made up of one atom, monoatomic. They're going to bond together, and we're going to deal with them separately. Let's first talk about the metal. Alright, sodium. We formed an Na+, and we also formed a Cl-. But this one first. What do we call this? Well, look right here. Naming a monoatomic metal ion, all you do is you take the element name, sodium, and add the word ion. So, we have a sodium ion. That's what we formed here. This is a sodium ion. Transition metals, remember those are those metals inside or towards the middle of the periodic table. They're a little bit tricky because they have multiple oxidative states. Sometimes iron will lose 2 electrons. Sometimes it'll lose 3. So when you name these, you have to specify with a Roman numeral how many electrons it's losing. So lead sometimes will lose 2, so you have to call a lead ion, but you have to include the Roman numeral. Sometimes lead will lose 4, giving an oxidative state of +4. You have to include that +4. Same with carbon. Sometimes it loses 1 electron, sometimes it loses 2. But these are easy. Sodium ion. This is a strontium ion, a zinc ion. That's how we treat metal ions. All right. How about nonmetals? Well, we have our sodium ion. What do we call this guy? It's not a chlorine ion. When a nonmetal forms an ion, here's how it's named. You take the element stem name, which would be chlor, and you add "ide," chloride, in the word ion. So we have a sodium ion and we have a chloride item. or ion, I'm sorry. Oxygen. When it becomes an ion, we call it an oxide ion. Nitrogen, where's our stem? Add "ide" and the word ion. Nitride ion. So let's put this together. Let's name NaCl. Well, we said we have a sodium ion. Here's our Na+1. We have our remember "ide", we have to use "ide" for the nonmetal ion. And once we have this sodium ion and chloride ion, all you do, cross out the word ion, combine what you have left. What do we have left? We have sodium. Oops, let's go back. We have sodium chloride. And that's it. We named it. Sodium chloride. Name your metallic ion, sodium ion. Name your nonmetallic ion, chloride ion. Cross out ion. What do you have left? There you go, sodium chloride. Polyatomic ions. Sometimes ions exist as multiple atoms. Alright, here. NH4. This is 5 atoms in this particular ion. Hydroxide, cyanide, chromate, dichromate, etc. These exist as a whole, and as a whole they have a positive charge. This hydroxide as a whole, this negative charge applies to the whole thing. Same thing with the chromate. These are the things that you just kind of have to commit to memory. Sulfate is SO4 with a -2 charge. Notice that pretty much all of these are anions, except for ammonium, which is a cation. So, if we were going to combine these, remember this is going to be ionic, an ionic bond. We have a cation and an anion. All right, we have potassium and we have sulfate. Well, how does this work? Here's our positively charged cation, our negatively charged anion. They're going to be attracted to one another, and you use a crossing over method. Okay, so this number is going to go down and tell you how many potassiums you have. Well, we're going to have 2 potassiums. This number, 1, comes down and tells you how many sulfates you have. I'm going to put this in parentheses, SO4. I guess you don't really have to. But there's 1 of them. You don't need to put the 1, but I'm just showing you. So what you would have is K2SO4. You don't need to put the 1 in. And this is potassium sulfate. Just this ion, this is a potassium ion. This is a sulfate ion. Get rid of the words ion, right? What do you have left? Potassium sulfate. Let's try this. We have a magnesium ion, and up here we have a phosphate ion. Magnesium ion, and we have a phosphate ion. How do we add those together? Well, that crossing over method. We're going to have 2 of the PO4s. We're going to have 3 of the magnesiums. Magnesium 3, PO4, 2, and what do we have? Cross out ion. We have magnesium phosphate. There's our polyatomic ions. Lastly, naming molecular compounds. This is pretty easy. A molecular compound is formed by 2 nonmetals covalently bonding together. And we use these Greek prefixes. We don't often use mono, it's usually omitted as it says here. But it's going to indicate how many atoms of each element are in the molecule. 1 is mono, di, tri, tetra, penta, hexa, hepta, octa, nona, and deca. So, showing you here. The first element, you get the Greek prefix plus the element name. This is phosphorus. Well, how many of them? Diphosphorus, pentaoxide. Alright, and remember we're using that "ide" again for our second element. We're using "ide" just like we did before. Remember we omit the mono, don't use it very much. Sulfur, hexafluoride. There's our ide again. Hexa, meaning that there's 6 of them. There's our Greek prefix. Pretty easy. This one. Name your first element. Well, that's carbon. Greek prefix shows you how many of these are. There's 2 of them. Di. What is it? It's oxygen, but we have to use ide, so we use the stem. Ox. Ide. Carbon dioxide. Pretty simple for molecular formulas. So just a quick overview of how you name them. Hopefully that helped.